So waves, they travel, it's an energy traveling over a particular distance, and because it's traveling a distance, it takes some time to do it. And it travels at a certain speed. So waves travel a distance and they take time and they travel a speed. So we can actually calculate the speed of a wave, or the distance a wave has traveled, or the time a wave has taken to travel by using a very special formula. So it's the formula for speed or velocity, and I've drawn it here as a triangle, which is a little bit strange. But there's three symbols here. One is distance, one is velocity, which is speed basically. So distance is d, velocity is v, and time is t. So time is in seconds, velocity here is in meters per second, and the distance is always measured in meters. So if you're going to do these calculations, you've got to make sure that your distance is always in meters, your time is always in seconds, and your velocity is always in meters per second. Otherwise, it's not really going to work out right. So we can use this little triangle here to figure out the speed of things. And it doesn't matter if we're given any two of these things, whether we're given whatever of the two, we can figure out the third. So for example, if we're given the distance and the time, then we can figure out the velocity. So if we want to know the velocity, if we circle the other two, then velocity equals distance divided by time. So velocity equals distance divided by time. That's one. If we want to calculate the distance, let's circle the other two. Distance equals velocity times time. So that's over here. Distance is velocity times time. And the last one here, if we've got the time, we want to figure out the time, we've got the distance and the velocity. The time equals distance divided by velocity. So it doesn't matter which one we're missing or which one we want to find out. As long as we've got the other two, we can figure out the distance or the velocity or the time. So I'll give you an example here. So let's say I want to find the velocity of a wave, and I've got the distance and the time. If the distance a wave travels is 1,500 meters, so 1.5 kilometers, but I've got to put it in meters, 1,500 meters, and it travels it pretty fast, travels it in 4 seconds. This is probably a sound wave. 1,500 divided by 4 is equal to 375 meters per second. Sometimes when people write, instead of writing meters per second, they write meters and seconds to the -1. So these both mean the same thing. It's meters per second. So that's an example of calculating the velocity or the speed of a wave as long as I've been given the distance and the time. I'll give you another example here is I want to calculate the distance. So I've been given the velocity and the time. So the velocity of this wave, again it's a sound wave, is traveling 330 meters per second. And it takes 3 seconds. So how far has it traveled? Well, 330 times 3 is equal here to 990, and these seconds here both cancel each other out. So it's equal to 990 meters. So that's a couple of examples of using this, the equation to calculate speed. And we can use this equation, or really this triangle I've drawn here. To calculate either the velocity or the speed of a wave is distance divided by time. The distance is velocity times time, and the time is distance divided by velocity. You've got to make sure the units are right. It's meters for distance, meters per second for velocity, and seconds for time. And that's really how you calculate the speed of waves, and also how you calculate the distance that a wave has traveled or the time it took to travel it.